Good afternoon, students. Welcome to the 31st lecture. Welcome to 31st lecture of refrigeration and air conditioning subject. So we are in the third unit. So we are discussing the last topics of unit 3. So today's topic to be discussed is vapor compression refrigeration system components. In that already we have discussed the condensers, evaporators, expansion devices or throttling devices. The last component to discuss is introduction to the compressors. So we will discuss the topic called introduction to the compressors, the applications, the functions of compressors, the classification, and some of the problems, right? Yes, we'll enter into the class. Okay, so we already know that the definition of vapor compression refrigeration system working on vapor, right? So other thing, we are having absorption compression system. So in the unit 3 we are discussing about the vapor compression refrigeration system and the components. So we know what is the meaning of condenser, expansion devices, evaporator, and the fourth important device is compressor. Okay, now see here, the refrigeration system controls the absorption and rejection of heat. Absolutely, the refrigeration system, it may be a fridge or it may be the air AC. It will absorb the energy and rejects the energy, absorbs the heat and rejects the heat by refrigerant to move heat from inside a cooled space to the outside cooled space. So if you see AC, so inside we are having cool, outside we are having hot. Here what it does, the refrigerant makes to move the heat. The refrigerant makes to move the heat from inside a cooled space to the outside the cooled space. See the figure here. This is the air conditioning system. Okay, so this is outside atmosphere, this is the inside atmosphere. Here the hot air is going out where it is located in this cool space. Okay, here the warm air in the room is going in this direction, thereby the fan takes the air and passes in this direction, and it hot air is going outside in this direction. Now the refrigeration system, what it does, outside the cool air is going inside this one, right? Again it is passing into this chambers, and the cool air is going into the room. Here what happens here, the heat absorbed by refrigerant in the system. Ante whenever we are in a room, whenever we switch on the AC, the heat absorbed by the refrigerant in the system, and heat is rejected refrigerant in the outside the system. So what happens here, the whatever the refrigerant we are using, freon or 11, 12, 21, 22, whatever it is, the refrigerant is rejected at the outside point, the refrigerant is absorbed at the inside point. Okay, so here we are getting the cool air inside, the warm air is going in this direction and away in the box to outside the unit, it is going in the hot air formation. So this is happening in any type of refrigeration, or it may be the refrigerator, that is a fridge also, right? Next, so you understand the figure, right? Very simple figure to explain. Next one, in mechanical compression refrigeration system, a compressor is used to produce the refrigeration effect. So what is the compressor function, what is the use of compressor? The use of compressor, okay, the use of compressor. So here the use of compressor is to produce the refrigeration effect by taking the refrigerant as a medium. Okay, here what does a compressor do? A compressor, it will produce a refrigeration effect, means a cooling effect, by using the refrigerant as a medium. Now if you see the refrigerator concept, the mechanical compression refrigeration system. So the cool air is coming outside in this form, cool air to the cool space. This is the evaporator where already we studied in the last class. So inside this coil, inside this tube, the vaporizing refrigerant is present. See here. So the dashed portion provides the high pressure side and the low pressure side. So the low pressure sides we are calling them as a cryogenics. So that will deal in the other subject. So the high pressure side is above this one. So the low pressure side is the refrigerant is in the vapor form. The high pressure side is the refrigerant is in the liquid form. See here, the liquid refrigerant. Okay, the liquid refrigerant. Now see here, we are discussing this compressor point. So already we have discussed the condenser. The condenser, దీని గురించి మనం already we have completed the topic. So we have completed the evaporator, we have completed the expansion devices, and we are discussing about the compressor point, right? Now see here, we are having two fans. One is unit 1 and unit 2. In the outside unit low we are having a fan, inside unit also we are having a fan here. Now see here, the warm air from cool space, the warm air, cool space low, no warm air is going in this direction, right? The warm outside air, whatever the B box which is present at the outside of the room, the warm outside air, here the hot air is going out, here the cool air is going in. Here what happens here, yeah. So here the hot air, the condenser, what does it do? Heat carried away from the refrigerant. The condenser will take away the heat carried away from the refrigerant. Here the refrigerant is will carry the heat inside the pipeline. Now the condenser will what will do? The condenser will take away the heat from the refrigerant. Refrigerant means a chemical, a substance which is used for refrigerating system. It may be the fridge or it may be the air conditioning system. Now the liquid refrigerant is passing through filter or dryer which will filtrate the dust or other particles and passes inside the tube, right? So the metering device is used for checking the refrigerant specifications. So once the refrigerant is passing from the condenser, it is going to the evaporator. So when the refrigerant is in the liquid form, see this color portion is a liquid form, the dotted portion is slowly converting the liquid form into the vaporized form. So whenever the refrigerant is passing into the evaporator junction, slowly it is converted into vaporized refrigerant. చూడండి, vaporizing refrigerant, here is liquid refrigerant. Therefore the liquid is going in this way slowly, it in this evaporator, due to the heat in this evaporator, see the warm air due to the fan blower, so it is converted into vaporized refrigerant and we are getting the cool air. Now the vaporized refrigerant is passing away these in these coils, and again this vaporized refrigerant vapor is passing into the compressor in order to produce a refrigeration effect. Now the from this compressor, again the refrigerant is condensed and passing into this condenser. Again from this condenser, slowly it is passing into the fins, again it is converted into the liquid form, and again the cycle repeats. So in this way the mechanical compression refrigeration system works. Now we have already discussed the concept of condenser, the types of condensers, the classification, the properties of condensers, the applications and the types. In the same way, we have discussed the evaporator, the classification of evaporators, the types of evaporators, and the functions of evaporators. And we also discussed the expansion devices. Now, the last component to be discussed in this unit 3 for VCR, vapor compression refrigeration system, is compressor, right? Yes. Next, the refrigeration compressors include various types of systems. One is reciprocating type, vane type, centrifugal type, screw type, other positive displacement type. Now we'll see each type of compressor in detail in this session and coming tomorrow's session also. Now see the basic compressors, how they look. So the commercial type of refrigerator is reciprocating, centrifugal, screw type and vane type. Okay, so if you see here, the reciprocating type of compressor, reciprocating means moving to and fro, moving up and down, moving left and right, or moving sideways, whatever it is. Means reciprocating means moving in either direction, just like to and fro, front and back, like that. Now here, how the piston is moving here, the piston is moving up and down, up and down, up and down, just like your engine, right? Here also what we are doing, we are sucking, we are taking the refrigerant, we are taking the refrigerant by using this mechanism. So the compressor takes the refrigerant and pushes into the condenser from the evaporator by many forms. In that many forms, we are using this compressor form. What is this form? Reciprocating type, reciprocating type, vane type, screw type, and centrifugal type. Now see, in the reciprocating type, the piston is moving down, so the crankshaft is rotating like this. Therefore, when the piston is moving up, the crankshaft is released in this figure. Thereby, during this action, in the same as in the engine, in your automobile or thermal subject, how it happens, the same way also here the concept happens. Here, the cylinder head, here there is a suction line from the evaporator. Evaporator లో దీనికి వెళ్ళి తర్వాత ఇక్కడి నుంచి దేనికి వెళ్తుంది, కండెన్సర్ కి వెళ్తుంది, రైట్? సో ద సక్షన్ వాల్, ఆల్ ద ప్రాసెస్ is same. So here it is connected to the crank pin, crankshaft. There is a crank pin, right? There is a crank pin, there is a crankshaft, there is a connecting rod. Connecting rod is connected to the piston. These are the pins. So this is a suction stroke, this is a compression stroke, right? So see here in the compression stroke, what happens? Discharge line to the condenser. Here suction stroke low, suction line from the evaporator. So this is reciprocating. So if you take a vane type of compressor, so you are having a casing, right? A rotary casing, you are having a spring, you are having an inlet port and outlet port, and this is a rotor mechanism. So you are having two slots like this, and this is a compressor casing. So in the same way, whenever the shaft rotates due to the motor, it will also rotates in this direction. So whenever it rotates in this direction, so due to this process, due to the action, what happens? The inlet port takes the suction line from the evaporator. The outlet port takes the discharge line to the condenser. So in this way also, the refrigerator is moving. That is in the vane type. Next, coming to the centrifugal type. So the centrifugal type is just like a snail type, where the drive shaft is in this way. So whenever the drive shaft rotates, so the impellers start rotating. Thereby you are having inlet port and this is a outlet port, right? So this is a shell type of housing where you are having the impeller wheel inside the housing. So during this process, so it rotates, and in the linear type, the output come outside, right? This is a form of centrifugal. And coming to the screw type, see the view of a screw type. So this is a internal view. So ఈ portion ని మనకి అవుట్ సైడ్ ఇలా చూపించారు, రైట్? దిస్ ఇస్ అ ఫిమేల్ రోటర్, దిస్ ఇస్ అ మేల్ రోటర్. సో ఇట్ ఈస్ స్లైడింగ్ over one over the other, just overlapping, and the outlet port in this way, the inlet port is, so this is inlet port going down, this outlet port in this direction. So here also the same thing happens, but the mechanism differs based upon the mechanical members. So in this way, we are having various types of compressors, how the liquid refrigerant is going from evaporator to condenser via compressor in the vaporized form. We will discuss in the coming classes. No one is attending the classes regularly, huh? Now, refrigerant compressors are available in hermetic and semi-hermetic configurations. So the mechanical setup of the refrigerations we are seeing in the two types. One is hermetic refrigerators and semi-hermetic configurations. Now see the hermetic. Now see the hermetic system and semi-hermetic system, right? So crankshaft, the pistons, this is a motor, this is a casing, right? So this is a Techmish Products Company. So this is the same thing. Copeland Corporation, manufacturers of these motors. So this is a motor, this is access plates, and this is a compressor located at the top. So these are the configurations showing which are available in hermetic and semi-hermetic configurations. Next. Yes. Then what is the meaning of a compressor? Right? What is the meaning of a compressor? A compressor is a one which takes a definite quantity of a fluid. Right? A compressor, it is a device which takes a definite quantity of a fluid, usually gas and most often air, and deliver it to the required pressure. Okay, it takes the definite quantity of so the fluid కావచ్చు or in the form of gas or mostly in the form of air and delivers it to the required pressure. So if you see the air compressor, it takes in the atmospheric air, it compresses the air and delivers it to the required storage reservoir. The compression requires the work to do and to be done in on the gas. The compressor requires work to be done on the gas. Compressor must be driven by some sort of prime mover, that is engine. So what it is saying? So the compressor is a device where it carries the quantity of a fluid or a gas or air and deliver it to the required pressure, but it should be driven by some sort of prime mover. Prime mover ante which starts at the initial point, right? The prime mover is nothing but a engine. Next, a compressor will act as the heart of a refrigerant based mechanical cooling system. So if you take a refrigerator, ఇంట్లో ఫ్రిడ్జ్ కానీ ఇంట్లో ఏసీ కానీ, so for that what is the heart? The heart is compressor. So the compressor will act as a heart of a refrigerant based mechanical cooling system, and its functions include drawing the cool vaporized refrigerant that carries the heat energy from the evaporator coils. So ఇందాక మన figure లో చెప్పుకున్నట్టు, so this is a sentence form, compressing it from the low pressure temperature to the high pressure temperature and pushing it around the refrigeration. So that is a definition of a compressor. Now what are the characteristics of the compressor? We will see now. So coming to the characteristics of a compressor, the first one is the constant speed or variable speed. So coming to the speed characteristic, we are having both type of speeds. One is fixed, one is constant speed, other one is a variable speed. So which we have a driving speed. The second characteristics is, so it has a number of stages. It has a number of stages, that is single stage type of, second two stage type, and multi-stage type of compressors. Next, third one is drive types. Third one is a driver types. So in the drive types, we are having the motor, we are having the engine, you are having the belt assembly, the chain assembly, etc. Next to the structure, the configuration of a compressor, we are having an open type, we are having a closed type, we are having a hermetic type, and semi-hermetic type we are having. Coming to the method of cooling, coming to the cooling method and medium of cooling, we are having air cooled system, water cooled system, and oil cooled system. So among the three, water cooled system is lesser than to the oil and other things. Next characteristic is lubrication method. So how we are doing lubrication into the compressor, how we are pushing, how we are sending the lubrication to the compressor whenever it is in action. So we are having various methods. One is splash type, mist type, forced lubrication, and oil-free lubrication. So like this, we are having various methods of pumping the lubrication into the into the compressor. So these are the characteristics of any compressor which acts with a mechanical based refrigeration cooling system. So that's why we are calling them as the heart of a refrigerator. Got it? So so these are some of the characteristics that should keep in mind how the compressor will react, right? Got the point? So we'll switch on to the next point. Sorry. Okay, we are having the same slide two times. No issues. Yes. Coming to the functions of a compressor. So till now we have discussed about the introduction to the compressor, why we use compressor, the layout of a compressor, the characteristics of compressor, and the functions of a compressor. So pumps refrigerator vapor. It pumps. The compressor pumps the refrigerant vapor, which is the heart of a system. Next, it increases the refrigerant pressure. What does it do? It increases the refrigerant pressure at the suction pressure to the discharge pressure. In the previous slide I have shown you the high pressure, high side system and low side system. So what happens in the suction pressure, it will rises, and in the discharge pressure it will also rises. So therefore the compressor increases the refrigerant pressure అని చెప్తున్నారు. Next, it increases the refrigerant temperature also. So what happens finally, the compressor will move. The compressor will increase and decrease the compressor will always increase the pressure and temperature, right? Raises suction temperature above the ambient temperature. The high temperature vapor can be cooled by ambient vapor is condensed into the liquid for metering devices. So these are the functions of a compressor. Next. So somehow we want to show it in this animated figure. Now see here what happens. So what it is saying here, it is saying that the pump will act as a the compressor will act as a heart of the system. Here the pump's refrigerant. See the figure here. See the figure here. So in the initial stage, one second. Yes. So from the compressor, the heart of the system, right? The heart of the system. Now from here, the liquid refrigerant is passing from evaporator. Now see the animated figure. Here the pump refrigerants, right? Pumps refrigerant. See how the refrigerant is going inside. So see the white is converted into blue color. It will pumps and the see here the refrigerant changed the color from blue, light blue to the this form. Slowly it is going into the coils and passes into the condenser, right? So whenever the pressure increases, what happens? 69 psi per grams to 78 suction and discharge. Now the increases temperature also. Now what happens? See here. So whenever the temperature is increased to 60% to 125 degrees. See here at this position. So the temperature is 60 degrees, but at this position the temperature is 125 degrees. Thereby the liquid is converted into vaporized form. Now at this ambient seems cool. So at this point the condenser vapor, the ambient air is 95 degrees. Therefore it is directly passing into the condenser zone and providing the liquid to metering the device. But so this happens in the compressor, which is shown in the animated type, a brief type. So how it is providing the liquid to metering devices. Got it? Yes. Coming to the applications of compressors. Compressors are used in daily applications in many cases. See the first one, air conditions. So air conditions ఎక్కడ ఉంటాయి? We are using air conditioners in office, homes, industries, cinema theaters, cars, buses, lorries, carriages, etc. So we are using there. Next, pneumatic devices. So in the pneumatic devices, such as for example JCB, motor grader, in heavy earth moving vehicles and other some other things, we are using the compressor for pneumatic devices also. Next one is home and industrial refrigeration. So already మనం చెప్పుకున్నాం. So for both for both type of applications, either it is window type, split type, or central AC for home or industry. So we are using the compressors. Next, hydraulic compressors for industrial machines and air compressors for industrial manufacturing. So like this, the compressors word, the use of compressors are widely used in almost all sectors in order to fulfill the work and complete the task within less time. So that is the main thing we require now, right? Fast service, right? Next. Yes. Coming to the classification of compressors. So the compressors are classified, that is impossible to say. So the compressors are classified in many ways, but according to the some points, the compressors have been categorized. Coming to the first point, compressors are classified according to the method of compression. First thing is according to the method of compression. ఎలా compress చేస్తుంది? First thing is the compressing the refrigerant by reciprocating method, right? Reciprocating method, rotary method, and centrifugal method. So basic three ways, that is by reciprocating compressors, rotary compressors, and centrifugal type of compressors. These are the three ways according to the method of compression. Okay, the next one. Second one is according to the number of working strokes. So according to the number of working strokes, we are having single acting working stroke and two acting working stroke. Next, coming to the third category, we are having according to the number of stages. So how many stages does that activate? So according to the number of stages, we are having single stage or single cylinder compressors, multi-stage or multi-cylinder compressors. Next, fourth classification, according to the method of drive employed. What is the type of drive? How you drive according to the method of drive employed. So we can use both drive, belt drive control, and belt drive control, right? So we can use both the things, that is belt drive method and direct drive method. Next, fifth one is according to the location of prime movers. According to the location of prime movers means what I said. The first మీకు నడవడం, the first thing, how you learn on your own. In the same way, you are having the location of the prime mover by using hermetic compressors, where you are using belt drive motors compressors in the same housing. So if you see the semi-hermetic compressors, there you use a driver system, belted system, right, motors type, and compressor in separate housings. So these are the two both problems for this classification. Why? Because the classifications based upon the location of prime mover. So it depends upon the application, how you are using the resources. Based on that, it will be changed. So finally, the classification of compressors are of 5 types according to the method of compression, according to the number of working strokes, according to the number of stages, according to the method of drive employed, and according to the location of the prime mover. So these are the 5 types of things. These are the 5 types of things where we are using uh, uh, so this is one type of classification. So in the next slide we can see the other type of classification also, right? So see here, number of working strokes, number of stages, driving employed, and location of the prime mover. Next one. So we can classify the compressors in this form also. So coming to the compressor types, we are having dynamic compressors and positive displacement compressors. Coming to the dynamic compressors, we are having 2 types. One is centrifugal type of compressors, other one is a axial flow type of compressors. Next, coming to the positive displacement, we are having again 2 types. One is reciprocating type and other one is a formatting type. Coming to the classification, in the positive displacement type, you are having 2 types. One is reciprocating type of compressors and rotary type of compressors, right? So under the reciprocating type of compressors, we are having a single acting reciprocating compressors, double acting reciprocating compressors, and we can use the diaphragm type of reciprocating compressors. Next, coming to the rotary type of compressors. So from this positive, we are having a reciprocating type, we are having a rotary type. Again, from the rotary type, we are having vane type of rotary, lobe type of rotary, scroll type of rotary, liquid type of rotary, and screw type of rotary system. So like this, the classification of compressors are classified into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 types of compressors are available in the market, but it depends upon the specification and depends upon the customization. You have to select it. Now we'll discuss each one of them of these compressors in detail. Okay, so before that, first we'll see how the compressor will work. Okay, how the compressor will work. So compressor first stroke. So the first stroke, the piston getting down. The first stroke, the piston gets down. Here what happens, whenever the piston drops down, the lowers the pressure in the cylinder. So absolutely, whenever the piston comes down with the crankshaft, the piston lowers the cylinder, right? Lower pressures in cylinder. Next, it pulls the intake valve open. So అంతకు ముందు సైకిల్లో the intake valve is closed. Whenever the intake stroke low, whenever it comes down, automatically it pulls the intake valve open. Therefore, the vapor is sucked inside the cylinder. The vapor is sucked inside the cylinder during this piston drops. Okay. Yes. So what does the piston do? The piston will is sucked into the cylinders and it cannot live inside the things. Okay, so now see the animated stroke. So how the action does. Okay, so this is what this one is, one side, this one is the inside, this one is the outside. Next, so this is a inlet, there is a outlet. Now see how the crankshaft will rotate. Right, now see how it is going. See how the vapor refrigerant is falling in the piston. See how the crankshaft is moving from up and down, all over on the top. Okay, now see the valve opens at the top of the piston. Now the compressor, what will do? The compressor will suck onto the system. So whenever the blue color portion is showing in such a direction, automatically it will enter into the system. Right? So coming to the end of the intake stroke, so piston, when it is going maximum to the BDC, that is bottom dead center, maximum it is going to the BDC, what happens? You are having till 10 more minutes. Okay, now reason here. So whenever the piston is going at the bottom level, once we call to his house on this thing, so the piston at the bottom, what happens? The cylinder pressure equalizes the medium. So that's piston at bottom position. The cylinder pressures the pressures to equalize. Next, intake valve closes. So for this intake of a intake stroke, we are using the cylinder pressure equalizer and cylinder ball mismatch, so we didn't get it right. Okay, now see how the process goes. See how the liquid is going inside the casing. Now see the valve closes at the top. So the third one is a compression stroke. First two things are over, right? So the third one is the compression stroke. So what does in the compression stroke, we'll see now. So in this compression stroke, again the piston has to move up, so increases the salary, right? So in the piston compression stroke, it increases pressure to cylinder ring to discharge strange and so discharge the valve concepts. Now see how the liquid is taken by the water. Now see the pressure increased at that side whenever it is in the full condition. So it is a carry. Hello, vapor fully compressed at this point, right? Right. So whenever the vapor liquid is going inside the casing, see here the valve open at the top bottom side. So ముందు ఇక్కడ valve open అవ్వలేదు. So see the figure, see here. So the green color top switch is, so you can apply in this way. Now see, the piston rises, the piston is going down, slowly the valve opens. That happens in the second stage. Third stage is compression stroke, sorry. The third one is a compression operation, that is compression stroke. So here the piston again from the bottom it is moving to the top. So at that point the cylinder pressure equalizes and discharge valve closes. Therefore the small amount of discharge remains. Now the discharge valve closes here. The small amount of discharge gas remains. This is called what? Clearance volume, VC. This is called clearance volume, right? Next one is this stroke is nothing but the clearance stroke or a volumetric stroke. There is a clearance stroke. This effect is nothing but a clearance volume stroke. That is a third stroke. Next, see the animated figure here. Now see here, compression తీసేసాము, vapor fully compressed. Now the piston is coming down. See the pink color portion, how it is forming there. Now when it is forming there, what happens when it is forming at the nearby proximity, then automatically the, see here now, so it is slowly pushing up. So from there it is just to join our cap. So we directly come to cabin, cardiac, right? Now see here, the valve opens at the left side. See the red color portion, how it is going inside the condenser from the evaporator. Okay, now the blue color portion, the blue color portion is the refrigerant is going inside here, but the energy released is coming out in the form of red color and it is discharging into the condenser. Now the next stroke, piston at the top, the same point. Okay, no issues. So why two times it is coming? Now see the downward stroke. When the piston again drops, the gas in the clearance volume re-expands. So in the figure low, the gases in the clearance volume get expands and the cylindrical pressure will drops. Therefore, the reciprocating compressor inefficiency is opening down. The compressor energy is wasted during the re-expansion. Okay, so the compressor energy is wasted during the re-expansion process. Now see here, the piston at the bottom cycle completes and there will be the conserve. Okay, now in the each cycle, what does we do? In the each cycle, in the suction side, we are having re-expansion. In the compression side, we are having the discharge. In the following three continuous cycles, we will do the same process. Now see the complete cycle, how it acts. See here, see the valve opens, it is pushing up, the pinker portion pushes that valve open, it is coming down. Valve opens, so blue closed, pink is open again, forming with a red color, and again it is passing onto the chimney. So here at this point we are getting what? We are getting the energy. So at this point we are, where is the point? See, at this point we are getting the energy. So at this point, right? At this point inside the top surface of the piston. So with this we'll stop the class. The time is very less than 1 minute. So we'll discuss the tomorrow's class, the other types of compressors, classification of compressors, right? So no student were participated. So it's up to you. So have a nice day. So get your notes updated. So thanks for listening to the class. We'll discuss the class tomorrow at the same time, the classification of compressors in detail. So have a nice day.